Hi geometry students, this is our notes for Unit 1, Lesson 10, and I'm on page 69 of our workbooks. For today's lesson, you might want to use some colored pencils or colored pens, just a few different colors. You can also simply use your pencil in your workbook as well. So on this first page, we're going to notice a few items about this diagram. So we're getting into lessons 10 through 14, which we're going to talk about reflections, translations, and rotations. And also we're going to be mentioning dilations. These are transformations that you might be familiar with from junior high. So let's take a look at this first picture. I want to point out some things that I'd like you to notice. First, we do have a dilation on our page. If you look at point O and you draw this line from point O, you'll see that S, this blue parallelogram, grows from a center O into this larger green parallelogram. If you remember, that was a dilation. Dilations change size. Dilations won't really be our focus for a few lessons. We need to know what they are because they are a transformation, but they're not what we call a rigid or fixed transformation. So let's look at an example of that. Let's look at our blue S and our pink M, these two parallelograms. Notice how the vertices are named A, B, C, D, and A prime, B prime, C prime, and D prime. That tells me as I look at this that this is the original figure. So the blue parallelogram was my original figure, and the pink parallelogram M is what we call our image. Our image comes after. So our original is first, and the image is what we get after our transformation. This particular transformation was a reflection. It was a reflection over line M. So let's look at why this is a reflection. If you use your patty paper and you trace your blue figure S, your blue parallelogram, on your patty paper, and you fold your patty paper over line M, we'll see that it lines up perfectly on top of our other parallelogram. So it's a reflection over line M. Reflections are one of our rigid transformations. That means our size didn't change. So write this down on this page. A reflection moves every point of a figure to the other side of the line of reflection and the same distance from the line. So I'm also going to add here perpendicular distance. So in this picture, if you'll grab a straight edge or anything that you've got nearby that helps you draw a straight line between A and A prime, B and B prime, and for instance, C and C prime. You'll notice that these purple lines that I just drew are perpendicular to the line of reflection. That's always going to be true. The point is the same distance on the other side of the line, but it's a perpendicular distance. So for instance, if I think about this triangle, if I think about this as the altitude going through the middle, A is 2 altitudes away from my line of reflection, and A prime is 2 altitudes on the other side. B is 2 altitudes to the line of reflection, and 2 altitudes on the other side. You could use the lines already there. For example, I go down 2 lines to get here, but then you don't want to keep traveling down 2 lines because you'll end up with B prime not where it goes. That, by the way, is a very popular mistake kids first make when they do this. If I'm going to go down 2 to get to this line, then I need to slide it in the opposite way, going back up 2 to get to the other side. That's something when your line is not vertical or horizontal, it can be tricky to do your reflection with counting. Let's try that then on the next page. So going to page 70, we have this activity on this page where we're going to practice some of these. Rigid transformations. Rigid transformation means it's fixed. My shape is not going to change size. It will not get bigger and it will not get smaller. It will remain exactly the same size. Let's first do a translation. It says translate figure S along line segment V. This, by the way, is called a vector. It's telling me how to move. This vector gives me direction and distance. So when I look at V, it's telling me both direction and distance. Sorry, I'll move this down to move each one of my points. So let's take a look at V. V slides down to the right, 1, 2. This is the point it starts at. This is the point it ends at. I know that because there's my arrow. So V is telling me to slide each point down to the right, 2. So let's do that. I'm going to get this orange color and I'm going to slide each point down to the right, 2. And I'm going to go get this one down to the right, 2. I'm going to go get this point down to the right, 2. I'm going to go get this point down to the right, 2. I'm going to go back in the back and get this one down to the right, 2. And hopefully you can see our figure emerge. If I connect my points, my 6 points that I have here, I get exactly the same figure. The entire thing has simply been moved down to the right, 2. And so this is going to be labeled, oh, it lets me label anything I want. So what do we want to call this? There's no A's on here. We'll call this A, and it's A. So I'm going to get a different color for the next one. It says to reflect figure S across line Y. Line Y is this vertical line in my picture. And vertical and horizontal lines are a little easier for students to reflect over. I'm going to show you how to do it with counting because I think it's more dependable with than patty paper, but I'll show you with patty paper as well. So this point, I want to move to the other side of Y, and I want to move it along a perpendicular line to Y. So if I think about this as 1 altitude, 2 altitudes, 3 altitudes, I'm going to count the same on the other side. 1, 2, 3, and I'm going to put my point. Let's do that all over again. 1, 2, 3 altitudes to Y, 1, 2, 3 altitudes on the other side of Y. Let's go get this guy. 1, 2, 3, 4. Let's go get this one. And finally, let's go get this guy in the back. He should be 5, I believe. 1, 2, 3, 4, 5 to Y. So count 1, 2, 3, 4, 5 altitudes after. Let's go get this one. 1, 2, 3, 4, 5 to Y. 1, 2, 3, 4, 5 altitudes down through the middle of my triangles. When I connect these 6 dots, I'll see that I get the exact same figure on the other side of my line. And we'll call him B. And I'll put B up here. You can also do this with patty paper. So for example, if I trace my S on here and my dots, and then this is my line of reflection. I want to fold it perfectly on that line of reflection. You can see that it completely overlaps the figure I drew on the other side. You can do your reflections this way as well. I find because the patty paper moves around, sometimes this isn't as dependable as counting to be able to get your reflection. So let's keep going. I'm going to grab a different color. Now we're going to reflect S across line M. There's some really popular mistakes kids make when they do that. So M is this diagonal line. Often this is what happens, so please don't do this. Students will count down 1, 2 to the line, and then they'll just count 2 on the other side, 1, 2, and they'll put the dot down here, and you'll get a figure down this way. Or some students will go this direction. They'll use these diagonal lines and count 1, 2, 3, and they'll just keep going on that same line, 1, 2, 3. They'll end up with a figure over here. The problem is remember what we did on the other page. Our line of reflection is this perpendicular line, or our line of reflection is M, and the line I'm reflecting with is perpendicular to that. It doesn't slide with this line, nor did it slide over here. It's not down here, it's not up here. It's directly across along this perpendicular distance is what we called it. So let's do the same thing here. My perpendicular distance would be this altitude, 2 altitudes to my line M. So I'm going to go 2 altitudes on the other side. So 1, 2, and I'm going to put a dot. And I'm going to do that again. 1, 2 altitudes, 1, 2 altitudes, and put my dot. So now let's do this one. 1, 2, 3 altitudes, 1, 2, 3 altitudes. Now let's keep going. 1, 2, 3 altitudes, 1, 2, 3 altitudes. And we'll do this one. And finally, we'll do this one. And I can already see my pattern. It's going to be right there. And I'm going to join my 6 dots. And I'm going to get this green figure. We'll call it C. And so that's my C. Pay special attention at home that your image is actually located along this vector they're calling W, and it's not up here and it's not down here, making sure that you reflected it across in a perpendicular way. I'm going to go ahead, you don't have to do this, but I'm going to connect my dots so you can see that purple line is perpendicular to my line of reflection. That's how I moved my green image. It's moved in a perpendicular distance across my line of reflection. So be careful with that. You can also double check yourself with patty paper. You can trace it and then fold it over line M, and it should be lining up perfectly on your green shape. So let's take a look at the next one. It says translate figure S along the line segment W in the direction shown by the arrow. So this is my arrow W. So remember, this is giving me W out to the side. This is a vector, and it's giving me direction and distance. So my direction is down to the right, and my distance is 1, 2, 3, 4, 5 triangles. From the beginning to where my arrow ends, I'm going down 5 triangles. Down to the right is important. That's my direction, and distance is 5. So let's see if we can do this. So let's go back up to this point. I'd like to move it down to the right 5. So 1, 2, 3, 4, 5 brings me to this point. We'll make this one purple. And let's do the same to this one. Down to the right 5. 1, 2, 3, 4, 5. And now this one, down to the right 5. 1, 2, 3, 4, 5. And down to the right 5. 1, 2, 3, 4, 5. And this one, 1, 2, 3, 4, 5. And back here, 1, 2, 3, 4, 5. Now when I connect my 6 dots, my 6 points, and I fill them in, we'll call this D. This figure, put that one there. This figure is slid down 5 to the right. So you can test it even with this. The way I would do a translation is I would hold my pen here and I'd start moving it down on my triangles. 1, 2, 3, 4, 5. And I would see it line up. So you can check translations also with patty paper if you wanted to. So I didn't turn it at all. It's not reflected. It just slid over 5 down to the right. So now let's reflect this across line Y. So that's pretty easy. This is my line, and my 2 points that are on my line don't move. That's a really important concept, and they ask you about it in your practice problems a lot. If the point is on the line of reflection, when you reflect it, it's still on the line of reflection. However, this point is 2 altitudes away from my line of reflection, so it moves 1, 2 altitudes to the other side. This point is 1, 2 altitudes away, 1, 2 altitudes on the other side. Same thing here, 1 altitude on the other side, 1 altitude on the other side. So now when I join this image we'll call E, and I think I will put dots here so it doesn't look exactly like the other side. And so the reflected image is called E. So D is my first image I got when I did the translation, and then I reflected it over Y, and that's how I got E. So how are all these images the same? Well, these images are all congruent because rigid transformations do not change the size. They do not get bigger, nor do they get smaller. And how are they different? Well, they've either been translated, or in this case, we did reflected somewhere else on my diagram. So activity 10.3, you and I are going to look at in class, this page right here. So go ahead and flip again to page 73, which is our summary. I want to highlight a few items. So this is page 73 that we're going to talk about in Zoom. So first of all, the actual definition of congruence. This is going to come up and it's important. A figure is called congruent to another figure if there's a sequence of translations, rotations, or reflections that take one of the figures onto the other. You might say, oh no, I thought congruent meant same size. You're right, but officially congruent to another figure means that you can do a sequence of translations, rotations, or reflections to take one figure onto another. The size won't change. The size does stay the same. So then I want to remind you what our rigid transformations were. We were just talking about these a moment ago. Those were our translations, our rotations, and our reflections. These are our rigid motions. This is different than a dilation, which we'll also be talking about this year. A dilation is not a rigid transformation, because it's not fixed. The size is not preserved, and it is not congruent. So we'll talk about these items in our Zoom. Thank you very much.